Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Unit 2, which is about systems and advanced math topics here. Systems are more than one equation or inequality, and we solve systems by figuring out like which ordered pair x, y value kind of makes both equations or all the equations true, okay? And so we've done that via graphing. We've talked about, we've graphed both linear equations and linear inequalities. So equations just like where they cross, the lines cross, but then the inequalities was where the graphs overlap because you're actually shading. And so now we're going to be doing stuff just using algebra. So this is called, we're going to be using substitution today. And so that's one way we can use algebra to kind of figure out where the graphs are going to cross, okay? So we have a warm-up here. I guess our essential question is how do we solve systems using substitution? And we have a warm-up here. So we're trying to evaluate the following expressions by plugging those numbers in and seeing if we can simplify them, see what the answer is. So go ahead and do the warm-up, see how you do. All right, so we have the quantity of x plus y squared, where x equals -3 and y equals 1. So we're just going to plug those in. So we got x is -3 plus y is 1 squared. So -3 plus 1, we do PEMDAS stuff, is -2 squared. And -2 squared is going to be 4. Okay, so this is kind of the basics of substitution. By substitution, we take something that's equal to and plug it into the other expression or equation. And so we've already done kind of substitution before, but this is kind of a more formal thing with systems that's a little bit more complicated. So it's good to kind of review this kind of process. Try number 2 if you'd like to, if you haven't done that yet. All right, so for number 2, we have p squared plus m for m equals 4 and p equals -3. So be careful. We know p is -3, so we're going to do parentheses -3 squared plus m was 4. And be careful, put the -3 in parentheses because it's different than just like without parentheses, right? So -3 times -3 is going to be 9, but if you do -3 squared in your calculator, you're going to get -9, which is not correct, okay? So 9 plus 4 is going to be 13. All right, so that's a basic form of substitution, and so we're going to get into like the actual solving for systems here, okay? So like we talked about, solutions to systems are where the graphs intersect or overlap. And so why don't you guys go ahead and try to fill in the blanks with your classmates or on your own, see if you can figure out what goes in here. Go ahead. So to solve, so the steps for using substitution is we're going to solve one of the equations for a variable. We're going to get it by itself. So it means to solve for a variable, so get it by itself. I can write that a little bit better. Itself. Okay. We're going to substitute or plug that expression into the other equation, the other what? For the variable that is by itself. So right, if it's x equals something, we're going to plug that in for x. If it's 2x, we're going to plug it in for x, not for y, okay? Be careful what it's asking you to solve. Like, whatever it's solved for, you got to plug that into what it's equal to, right? It would make sense to plug in x into y because it's not equal to y, it's equal to x, okay? Then you solve that equation, and then you take what you got. You're going to get something like x equals 4. And you're going to take that, and you're going to plug it in and solve for the other equation. So in this case, we would solve for the other equation, the what? Okay, and solve for the other variable. And your final answer, you're going to get x equals and y equals. It should be kind of an ordered pair like this, x comma y, right? So 2, -1 would be x equals 2 and y equals -1, right? So make sure you write like an ordered pair. It is possible when you're doing substitution or solving systems where they, we already get no solution. You get what? Or infinite solutions. What? So yeah, so it can be where they don't cross. There's no solution or infinite solutions. And you'll get weird results, which we'll talk about in this lesson too. Okay? All right, let's go ahead and do a few problems here. We'll try one, and you guys can try one here. So, or more, up to you. So we got number 1 is y equals -3x plus 18, and -3x minus 3y equals -6. First things first, in either of these equations is x or y by itself. Yeah, so on the top equation, you see how it's y equals. That's what it means for something to be by itself. So we have y equals. So what we can do, because y is equal to something, where we can take whatever y is equal to, and we're going to literally substitute it in for y, because it's y equals. We're not going to plug in for x, because it's y equals, okay? So it's kind of so we're going to say we're not really changing the equation. We're just kind of substituting and making it a little bit different. So we have -3x minus 3, parentheses, we're plugging in that -3x plus 18 equals negative 6. We didn't change it. This is still y up here. I'll put it down here for now so you can kind of see. This is still y, okay? Even though it's weird, this whole thing right here is y, okay? This is still y, even though it's weird now. But yeah, we just replaced the y with negative 3x plus 18, okay? Now what we're gonna do is we're gonna go ahead and solve, now that we have, in order to solve equations, we need like all the variables to be the same. So now that we have all x's, we can solve this, okay? So we're gonna solve this. How do we do that? We have some distribution to do here. We have the negative 3 times both of these. So we have negative 3x. Negative 3 times negative 3x is positive 9x. Negative 3 times 18 is negative 54. And that equals negative 6. All right. Anything else to distribute? No. Any like terms? Yep, we got 3x, negative 3x, and 9x, negative 54. So that's going to be what? 6x. Combine those like terms there. Minus 54 equals negative 6. All right, now we're solving for x. Got to get that 6x by itself. We're going to add 54. And we get 6x equals what? What's that? 48. Last step for this part, divide by 6. We get x equals 48 divided by 6 is going to be 8. Are we done? We are not. We have to make sure we get an x and a y for this here. So now what we do, the next step, is we're going to take this x equals 8. We're going to plug into one of the other equations and solve for y. Which equation do you think would be easiest to solve for y? The top one or the bottom one there? I probably plug into the top one because it's got y by itself. So we're going to plug into this equation. If you want to draw an arrow here, we're going to go like this. We're going to plug it in for x because x equals 8. So y equals negative 3 times 8 plus 18. So we can do negative 3 times 8 is negative 24 plus 18. So y is going to equal, what's that, negative 6? So now what's our answer? Our answer is not x equals 8, y equals negative 6. It's a point on the graph where they cross. We found it algebraically. What's the coordinates of that point? It's xy, which is going to be 8, negative 6. And that is substitution, okay? If you guys would like to try a couple on your own, feel free. Otherwise, we'll go through these right now. All right, number 2, we have negative 6x plus 2y equals 2. We have y equals x minus 5. Is x or y by itself in this either of these equations here? Yeah, y is. And just so you guys are aware, you can also like solve for x or get x by itself, okay? So doesn't always have to be y. I would just do what's easiest, right? So let's go do this here. So we have x minus 5 equals y. So we're going to plug in for x or y if it's y equals. We're going to plug in for y, right? Because it's literally y equals this, right? So now we can replace that y. So negative 6x plus 2 parentheses x minus 5 equals 2. So this whole equation on top, this whole equation just moved down here, and we replace the y with x minus 5 because y equals x minus 5, okay? If you want to pause it and solve from here, otherwise we're going to keep going. Anything to distribute? 2 times x, so we got negative 6x plus 2x. 2 times negative 5 is negative 10 equals 2. Anything else to distribute? No. Any like terms? Yep, negative 6x 2x is going to be what? Negative 4x minus 10 equals 2. Solving for x, we're going to add 10. Get negative 4x equals what? 12. So, solve for x by dividing by negative 4. We get x equals what? Negative 3. All right, then we're done, right? Not quite. We got to plug into one of these equations and solve for y now. Which equation would be easiest to plug in for, do you think? I'd say the y equals x minus 5 would be the easiest because it's kind of a nice thing. So we're going to take this negative 3. We're going to plug in for x because x equals that. So we get y equals negative 3 minus 5. So y equals what? Negative 8. So our answer is going to be negative 3. That's our x, and y is negative 8. All right, very cool. All right, 3 and 4 are kind of a trick question, but I put them on here on purpose to kind of see how we do. So if you want to pause and think about these, how we would do this. Otherwise, we're going to go right into it. Okay, so we have y equals 2x minus 4 and y equals 7x plus 6. So in this case, are x or y by themselves here? Yeah, y is kind of by itself in both. So what we're going to do is actually we're going to do the same thing. So we know y equals each of these. It's kind of the transitive property, right? If they're both equal to y, they're both what? They're equal to each other, or else we could take the 7x plus 6. We can replace y with that over there. But because they're both equal to y, they have to be equal to each other. So we do 7x plus 6, or you can just plug that in for y there, equals 2x minus 4. And then you would solve normally. If you want to pause it and try to solve it, give it a try. All right, how do we solve for x now? Subtract 2x. Okay, get all the x's to one side. 7x minus 2x is going to be 5x. Got plus 6 equals negative 4. Get 5x by itself by subtracting 6. 5x equals negative 10. 5 by 5. We get x equals negative 2. All right, we're done then, right? We are not. We got to plug into one of these here. Either one will be fine because they're both y's by itself. I'm going to plug into the bottom one here. So we got y equals 7x plus 6. X equals negative 2, so I can replace this x with negative 2. So I get 7 times negative 2 plus 6, which is what? Negative 14 plus 6. So y is going to equal negative 14 plus 6 is negative 8. So what's our answer going to be here? Well, it's going to be negative 2, negative 8, xy. That's the point where they're going to cross on the graph. We found it algebraically. All right, I want you guys to try number 4. It's just like this one, just a different kind of example of the same thing. All right, number 4, again, they're both equal to y, so they're equal to each other, or we can replace y in this equation with that, right? I'm actually going to flip them around here a little bit. So I'm going to do 3x minus 8 equals negative 2x plus 17. Either way, it's fine. I just like to keep the nicer numbers on the left usually. How do you solve for x now? I'm going to add 2x. So we get 5x minus 8 equals 17. Getting 5x by itself, we're going to add 8. 5x equals what? 25. Divide by 5. X equals 5. All right, we done yet? We are not. So I'm going to plug into the top equation here. Seems a little bit easier. So we got y equals 3x minus 8. Take this 5, plug it in for x. 3 times 5 minus 8. 15 minus 8. Oops, 18. And so y is going to equal what? 7. So our answer is the point where these systems are going to cross. The system's going to be a solution for going to be 5, 7. All right, very cool. All right, number 5 and 6, they're going to be a little bit weird here. It's going to be either no solution or infinite solutions. But why don't you guys go ahead and see if you can try these and see what happens. See if you can figure out, like, you're going to do the same thing. You're going to get x or y by itself, and you're going to plug it in. You're going to get something weird, though. I want you to think about what it is. Go ahead. All right, number 5. So we have 6x plus 3y equals negative 15. We have y equals negative 2x minus 5. Is x or y by itself right now? Yeah, we got y by itself. So we're going to take this, where we see a y in the other equation, we're going to replace it with y. So we have 6x plus 3 times negative 2x minus 5 equals negative 15. All right. Solve normally now. Anything to distribute? Yep, 3 times both of these. So we have 6x minus 6x. 3 times negative 5 is negative 15 equals negative 15. Now, if we combine like terms here, right, what's 6x minus 6x going to be? Well, they're going to cancel. They're going to go to 0. So what do I get left with here? I get negative 15 equals negative 15. Is that true or false? It is true. So how many solutions? Is it infinite solutions or no solution? It's going to be infinite solutions. If it's true, it's infinite solutions. And if you can't, like, there's no x left over, that's it. That's all you can do. They're basically, it's the same line on top of itself, just kind of rearranged differently. All right, now that we've done that, why don't you guys try number 6 if you weren't able to before and see if you see a similar thing here. Not going to be exactly the same, but give it a try. All right, we got y equals negative 4x plus 2, 12x plus 3y equals negative 4. Is x or y by itself here? Yeah, we got this y is by itself, so we're going to replace the other equation, the y, with negative 4x plus 2. So we get 12x plus 3 times negative 4x plus 2 equals negative 4. All right, anything to distribute here? Yep, 3 times both of these, so we get 12x, minus 12x plus 6 equals negative 4. All right, we distribute any like terms here. We do. These are going to cancel, though, so we get what? 6 equals negative 4. Is that true or false? That is false. So this is going to be infinite or no solution. This is going to be no solution. All right, very cool. So those ones are actually kind of nice because they come out to nice numbers here. Or they actually kind of cancel. There's a little bit less work to do, which is kind of nice. Okay, so on the next page we have some advanced and mixed practice. If you guys would like to try some of these first, might be a good idea. See how you do and then compare your work. Some of these you're going to need to solve and get x or y by itself first, okay? So, yeah, so I would probably get x or y by itself here. I would say number 10, I would get x by itself in number 10 just for foreshadowing's sake. I think just to make sure we see when we're plugging in for x as well. But give these a try if you would like to. Otherwise, we'll go through them in a second. All right, number 7, we got 3x plus 2y equals 2. We got 6x plus y equals negative 17. Is x or y by itself in these equations? Neither of them are, right? So, but which one will be easiest to solve for x or y, do you think? I'm looking for like a 1x or a 1y. Do you guys see a 1x or 1y in here? Yeah, see on the bottom we have 6x plus y equals negative 17. I would get this y by itself here. So how do we do that? We can subtract 6x here. And now you can see what we're going to have. We're going to have y equals negative 6x minus 17, okay? Now that we've done that, if you didn't know where to go from there, why don't you guys try to do the same thing as before. Take this negative 6x minus 17, plug it in for y in the other equation. Go ahead and see how you do. So we're going to take this, we're going to plug it in for y. So we have 3x plus 2 times negative 6x minus 17 equals 2. Anything to distribute? Yep, 2 times both of these. So we have 3x minus 12x minus 34 equals 2. Any like terms? Yep, we got 3x negative 12x, which is going to be what? Negative 9x minus 34 equals 2. Get the negative 9x by itself. We're going to add 34 to both sides. We get negative 9x equals what? 36. Solve to get x by itself, divide by negative 9. So we get x equals what? Negative 4. Are we done? We are not. We got to solve for y here. Now, the nice thing is if you get y by itself, you can actually plug into that equation you solve for, too. So I'm going to plug into there, make it a little bit easier. So I'm going to take this negative 4, plug it in for x. So I get y equals negative 6 times negative 4 minus 17, which is what? 24 minus 17. Which is going to equal 7. So our answer is going to be negative 4, comma 7. All right, very cool. Why don't you guys try number 8 if you haven't already? It's similar to one we've done in the lesson here. All right, is x or y by itself in either of these equations? Actually, y is by itself in both. So I'm going to take this 2x plus 15, which is equal to y. I'm going to plug in for y in the other equation. I'm going to substitute. So we get 2x plus 15 equals negative 3x minus 10. All right, now I got to solve for x. Feel free to go ahead and do that if you haven't already. I'm going to add 3x. So we get 5x plus 15 equals negative 10. Now what? Subtract 15. So we get 5x equals negative 25. Divide by 5. X equals negative 5. Are we done? We're not. We got to plug into one of the equations here. I'm going to plug into the bottom one. Plug in this negative 5 for x. Y equals 2 times negative 5. Plus 15. It's negative 10 plus 15, which is 5. So y equals 5. So our answer, xy, is going to be negative 5, comma 5. All right, awesome. 2 more. Feel free to try this one if you haven't already. All right, we have negative 16x minus 2y equals negative 4, and we have y equals negative 8x plus 2. Is x or y by itself here? Yeah, we got y by itself. We're going to take this, we're going to plug it in for y. it's y equals, we got negative 16x minus 2 times negative 8x plus 2 equals negative 4. All right, anything to distribute here? Negative 2 to both of these. We got negative 16x plus 16x minus 4 equals negative 4. Any like terms? Negative 16x plus 16x are going to cancel. We get negative 4 equals negative 4. This is a weird result. Is it true or false? It's true. So how many solutions are there? Infinite solutions. All right, very cool. And the last one, I told you, this one's kind of tough. So we got to solve for x, okay? So we have negative 6x plus 8y equals negative 8. We have 4x plus 4y, or sorry, minus 4y equals 12. So what I'm looking for here is the x or y values. I want to kind of see which ones are going to divide nicely. So if I divide everything by 4 here for x and y, those are going to actually make things pretty nice. So I would probably solve the bottom one for x. And so we want to get this 4x by itself here. How do we do that? We're going to add 4y here. Actually, with something like this, I'd probably cover something like elimination, which we're going to cover next. But for this case, it's like if you have to do substitution, it makes sense to probably pick an easier thing that's going to divide nicely, right? So we divide by 4 here. Divide everything by 4. We're going to get x equals y plus 3. All right, now we have x is by itself. So we're going to take this, we're going to plug in this y plus 3. Well, remember, it's x equals, so we're going to take this, we're going to plug it in for x in the other equation. So I'm going to write negative 6 times, let's write that better, negative 6 times y plus 3, replacing the x with that, plus 8y equals negative 8, okay? You should have all one variable when you substitute in here, otherwise you can't really solve it. Anything to distribute? Yep, negative 6 to both of these. We got negative 6y minus 18 plus 8y equals negative 8. Like terms, negative 6y and 8y is going to be 2y minus 18 equals negative 8. We're going to add 18 to both sides to get 2y by itself. So we get 2y equals what, 10? Divide by 2. Y equals 5. Are we done? Not quite. We got to plug in. I'm going to plug into the equation we made here, x equals y plus 3. So we're taking this 5, plugging in for y. So we get 5 plus 3, which is going to equal 8. So our answer is going to be 8 comma 5. And if it wants to go here, that is our solution, and that's all I have for you today. So thank you for watching. Have a great day, and we will talk soon.